sorry.
Hello.
Yep.
Yeah.
Other side.
Yeah,
Got
wrong
models
side.
here.
It's been moved and we forgot.
Bloody Batman.
We're a bit late. Now we're here. Right.
New unit.
Yeah,
it's
unit
2 of stats.
Stats from that book. Let's go into proper stats now. Yeah, last time I did a bit about spread, but this time has a few things different.
Yes. Like last time we spoke to you about the box and whisker diagrams, which are a measure of spread. They're not very good because they only measure the middle range.
Yeah.
So if we scrap that idea, we're going to go on to some whole new stuff today.
And it has a bit of new notation, so we're ready for that.
But first we'll do that, yeah?
Alright, let's do that. Okay.
Get out my pen. Oh, better.
Yeah. So, before we talk about the mean in the last video, this one, same equation, but it's denoted in a different way. It's got like an X and a bar of it, just past Wayne here.
X bar. So yeah, that's the mean, and this formula is exactly the same as you know for the mean. It's just this notation that's changed.
Yeah.
That's not a measure of spread, but that's used in the measure of spread,
used in measure
so
spread.
it's important. First one we're going to go, variance, I reckon.
I reckon we should go for variance. Yeah.
Let's do that now.
Okay.
Now, that right there, that little circle with a flick, is sigma, but it's lowercase, sigma. So like they're both sigma, but that's uppercase, that's lowercase.
Yeah. That's a symbol for variance.
Yep, that denotes variance, but another way they can do it is s, little x, squared is another way of denoting variance.
Yeah. So now we'll go through the equation of it, and that is, drumroll please, capital sigma x squared over n, take away x bar squared, just the mean.
Okay. So I should go through an example of this right now. If we I'll take a red pen.
Oh, red pen. I've got a red pen in my hand. Yes, that's handy.
Could you give me 10 numbers between 1 and 20, just completely at random?
Okay, I'll do a swap
a
list.
list.
Alright. 4,
4,
12,
12,
17,
17,
3,
3,
6,
6,
7,
7,
1,
1,
and 2.
2,
How many more do you need?
3, 4, 5, 6, 7, 8. 2 more, please.
15,
15,
and 19.
and 19.
It'll fit lovely.
Yes. So now we have a nice list of numbers, 10 numbers. It makes n easy, that's why I asked for 10. It's a proper number.
Yeah.
Sigma x squared means the sum of these all squared, so
4 squared plus 12 squared. As you can imagine, they give you a bigger list than that in the exam and it gets...
It's a nightmare.
It takes a long time, and that's why you should get one of these calculators.
Yes, I've got Casio FX9750G2.
Yeah, that's the calculator we use. They won't differ that much, but our buttons might be a bit different.
Yes, so I'm gonna run you through the ones on this calculator, the way to do it. On other calculators it might be slightly different.
It might be so different. Alright, so
places.
I'll write this out in blue.
Okay. So first, you're in your normal maths mode. It's just how you get the calculator. Press menu.
Menu.
And you can see you can do lots of different clever things with the calculator. You want to go to stats.
That's what we're doing.
And you will get lots of lists. And you want to input this list into list 1 section.
Alright.
4, 12, 17, 3, 6, 7, 1,
2, 15, and 19.
19.
Okay.
Okay. Then you want to press calculate, which is F2 in this calculator. 1 variable, which is then F1. And it will bring up all of these fantastic things.
Yeah, not all of them are that handy for us yet.
No, it does lots of things with that list. But the most important, it does sigma x squared for you.
Yeah, and it'll write it sigma x
rather
squared.
than you actually doing it. So, I'll write it down.
So, for this list of numbers,
Sx squared. Sigma x squared is 1, 1, 3, 4. N we know is 10.
yeah,
Minus the mean is 8.6 and that's squared.
alright. That means it's a bit nicer. You can skip quite a lot ahead, but in the exam you'll need to write all your workings, so this will need to be written down.
Yes, in case you're wondering how can you get marks if your calculator does it, you have to write down every step.
Yeah, so you have to know how to do it.
Then you go menu, back to the actual running maths part. then it's just a simple equation. You want to do 1134 divided by 10.
We could probably do that in our heads, but yes.
Minus 8.6 squared.
And that
Gives
equals...
you 39.44.
And that would be our variance. We don't stop there.
No. Because if you look at the equation, this is squared and then this is squared. If this is meters of something, I don't know, primary school children throwing a tennis ball or something, then this is all in meters. The variance will be in meters squared.
Well, that's not that helpful.
That's not that useful. You want your measure of spread to be the same as your list of what you're measuring the spread of.
So something else called standard deviation.
Yes, and that is denoted
as just sigma without the squared, because it is just the square root.
Or just sigma. So these are the
of
two
the
options of how it can be denoted. And it equals, because it's square rooted, it's just the square root and then of the exact same formula.
X squared over n, take away x bar.
And that's all square rooted, just to make it clear.
Because you already know, we've already done that bit, you just square root
we'll just
this
39.44.
Look now.
So square root of 39.44 is 6.28.
And that would be our standard deviation.
Yes, and that will be in meters, just like the list, if the list was in meters, which makes it really useful, and it is the measure of how spread out the data is. Like you see, this one ranges from 1 to 19, so it's not really a very good thing.
No.
Its measure of spread is very big, and that's not good.
And the standard deviation, I think it's all values will be within 2 standard deviations of the mean, or 90% of them.
Yes,
like
we get onto that way into the future.
We do, start doing graphs, but
a little mention now, you'll have something like this. Peak bell curves.
yeah.
The centre point will be your mean, x bar.
And most things will be within a set.
Yeah. Within 2 standard deviations of the mean, 99.9% of your data will be there.
That's quite a lot ahead.
That's a lot ahead.
That's normal distribution stuff, but
yes,
we'll
the two formulas and the new things to denote things that we're using now.
Yeah, I think that's
that is that.
That's pretty much standard deviation.
Let's move on with the book.
Alright, let's crack on. Alright, more questions.
Yeah.
Okay.
Slightly different to before, it's not just a list, it's a table.
Yes, and it's got a frequency on it, so it's a bit more complicated.
It slightly changes the formula.
It does.
But not a difficult way.
No, it just adds the frequency bit, like it did when we did the mean before, but has more impact.
If we go through this example first, this is a separate example, these aren't together.
Oh, there's not a red pen.
I've got a red pen.
Let's separate that. Oh, yes.
Let's go through this example first.
Right.
This is the number of visits to a doctor's in 6 months, i.e. 3 people didn't visit the doctors, 4 people visited them once in 6 months.
And so off.
So you've got a picture of what it is.
Yeah.
We've been asked to calculate the mean and the standard deviation of this. So how do we do that?
Well, there's 2 new equations.
Yes, mean denoted by x bar.
Yeah. Is sigma fx over n, like it was before.
Should we do that one first?
Should we do that one?
Standard deviation?
I think we should. Alright, let's do it.
Now, what this means is the sum of the frequency times x, plus that times that, plus that times that. Which, with this case, you could actually do in your calculator.
Yeah, you could do.
But I'm actually going to do it on the table thing, just to get you used to it.
Yeah.
So again...
So like before, go into menu, calculate.
I've already entered it in.
Calculate. Oh, we've already done it. Oh,
I've
okay.
already entered it in, so it's looking like this.
Yeah.
Then you want to calculate to one variable, and it will tell you all the different things. It already gives you the answer to the mean, which is nice.
Yeah.
But you've got to actually do the maths. You can't just write that down.
Yeah.
So sigma fx is the same as sigma x in this. This does it automatically.
Yeah.
But it's wrote like that. So sigma x in this case is 47.
Okay, so you're right, 47.
And n is 20, which you can check, just to check that your calculator's working, just add that up, and that should come to 20, which it does, that is 20.
Yeah.
So you know your calculator's right. And then 47 over 20 gives you what the calculator says the mean is anyway, which is like 2.35.
Yeah.
So it's quite a relief in the exam, quite a few marking points because you've got to be able to do it.
Yeah, you
Oh,
can
your
actually,
calculator will tell you that you've got it, and that's
yeah,
that's a
so you
good
can
thing.
you know you're right, and that's quite nice.
Yeah, I like
You can
that.
count definite marks in your exam, which you can't do in most of the others.
Yes, except you have to understand it a bit more.
Yeah.
Other exams, but
Okay, and then
Standard deviation.
deviation time.
noted by SX in this case.
Yeah, it could be or it could be lowercase sigma. Either works.
Yeah.
They're interchangeable. So before we have sigma x squared.
over n minus the mean squared. In this case, you simply put an f there,
Yeah.
and that's it. That's all that changes. And again, on your calculator, it will say sigma x squared. The calculator does the times f automatically
It does.
for you.
It says write the numbers in. So that stage now. So we
In
have
this, it's a square root of 167 over 20,
20.
because n's the same,
minus
what you just worked out.
2.35 squared.
Squared. And it actually tells you that answer as well,
It does.
which is nice.
It's very friendly.
1.68.
And that's standard deviation. You can see already how much time getting this calculator is saving you. Which
Yes.
is very valuable time in the exam.
Because the exam isn't that long. It seems like a long time, but it's not, because the
Yeah,
questions are quite heavy.
The questions are very hefty. You have to think about a lot of them in quite a lot of depth, especially the probability ones.
Especially that's the next chapter, in fact, chapter
Yeah.
3 is the next video. We have another example, slightly different again, but
Yeah.
pretty much the same thing. I'll give you my calculator.
Okay.
This is the time taken for school children to get to school on a bus.
Yeah.
Sort of a typical exam style question.
So 124 of them take between those two times.
205 take between 15 and 29 minutes.
And it goes on.
Yes.
Yeah.
So again, we've been asked to work out the mean, and
standard deviation.
I'm going to do the other. I'm going to do it that time instead of the SX this time.
Yeah.
We'll do the mean first again.
Okay.
It's the same formula.
We swap sides.
Same formula.
As before.
Sigma fx
Over n.
over n. But a bit more tricky this time. Because the f times the x is this frequency times the midpoint of this x.
So the first step really is to find the midpoint. So
What you can do is when you're I've got to delete all this. For the first list, to find the midpoint, add them together and divide by 2. And you
Yeah.
can do that in your calculator. You put in brackets 0 plus 14, you should be able to do it in your head, but 0 plus 14 divided by 2, and then press enter. It does the maths and enters the right number. So bracket 15 plus 29 divided by 2. 30 plus 44 divided by 2.
yeah. It's not very exciting. But you do this bit by hand. Calculator can't help you as much. You could put in another table, another column in your table. In the exam you might have to, sometimes they ask you to add a table of the midpoints. Sometimes when you do the cumulative frequency, that's when they get you to do that.
Yep, that's right. And then just entering in the frequencies, 124 into 205, enter 141, 87, 18.
Alright.
There you go. Calculating to one variable again.
Okay, so
Again, sigma x is what we're looking for, because it does the f automatically now that you put it in.
yeah, so it's 16,460.
16,460 over n, which is what?
575.
575, and it equals, and it tells you at the top.
28.6.
That's the only difference between this one and this one, and you've got to get the midpoint of these.
Yeah.
And sometimes that can be a bit of a nightmare. So let's write this one out again. We've got the square root
Of sigma x squared f over n minus x bar squared.
sigma x squared is what, Triv?
It is 633,477.5.
0.5 over
Same as for all
575.
575. Take away 28.6 squared. Running out of space a bit there.
Did it? And then equals, it's this x in your calculator, not just this as a symbol, but that is the standard deviation. What is it, Triv?
16.8 Wayne.
16.8. And this all seems pretty logical to do, and it kind of is pretty much a revision of GCSE. In terms of what you're doing, it's just new formulas.
Yeah.
That's all it really is.
It's quite a lot to remember, I guess, but
yeah,
it's not too hard.
Next is something that could clear up a lot of the stuff from your revision and from what we've been doing today, is what's useful about what of the different measures of everything, and the advantages and disadvantages.
What's wrong with each one, and why you should use one over the other in different situations.
Yes.
Alright.
But yeah, we're done this.
Let's crack on. We're back?
Yes. So, advantages and disadvantages of all the different things we sort of spoke about in this video and the last.
In some exams they ask you which one you use, what's bad about it.
Is this appropriate?
Yeah.
And stuff like that.
So we're just going to go through all the advantages, disadvantages of everything.
So we'll start with the mode.
Okay, start with the mode.
The most common value in a set of data.
Yeah. I might ask you why it's useful. You can use it in stuff like shops, which is the most popular item.
Yeah, so then they know what to stock, which is really good for them.
Which is really good.
Disadvantage, it doesn't really revolve around the central value. Or it might, but that would be coincidence.
Yeah, and it depends how it's grouped.
Yes, it depends how it's done initially. So for stuff like clothes, you can't really divide up so much.
No.
I mean, you can, it's different genres I suppose, but why would you do that?
Yeah.
Whereas
when
with stuff as like
lots of groups,
genders and stuff, it's really hard.
It's a bit awkward.
To use the mode.
Yeah.
Median.
Median. Yeah.
Useful because it takes the middle value, so it gets rid of the anonymous data on either side.
But it only takes the middle value,
which is also a disadvantage
because it gets rid of, leaves most of the data. And
yes. And it's really hard to program calculators to actually calculate the median, which is an issue.
It is
a disadvantage of it. Next we'll go for the top three there.
Alright. Yeah.
Advantages.
It does get the central value.
It uses everything, the whole data, so it's a proper representation of the data you've got.
It's a full representation of population.
That's also a disadvantage.
Yes, it can be affected by big anonymous data unless they're removed.
Yes.
Which is problematic. And then
but it's really easy to calculate, to make calculators do that, and express it as a formula.
It's much nicer.
Which is nice.
Now to spread and stuff.
Yes,
so
spread. So range first.
Yeah. Well,
range isn't fantastic.
No, it's sort of entirely dependent on extreme values.
Yes, so an advantage would be that it does use the whole data set. So it could be argued that if there was no extreme values, it would be really good.
But that's often not the case, so it would show an incorrect spread data.
Interquartile range, much like the median, its advantages because it takes the middle.
And gets rid of all the bad data. Yeah,
and its disadvantage, much like the median, is that it is solely the middle, it doesn't use the whole data.
Use the whole data.
So and it's really hard to get calculators to do it.
Calculators don't like that sort of thing. It's not very nice there's not a really nice formula for it.
Or anything like there's quite a few steps you've got to get up and lower quartile.
Yeah.
And then do stuff.
So it's not so friendly.
And finally, what's the last one?
Standard deviation, variance.
And variance, we'll just group them as one.
We'll group them as one.
Because they're the same thing, just one description.
Yeah, they're the most preferred one for calculators and all.
Yes, they're easy to program into calculators, that's
very nice formula.
They use the whole data.
They do.
They give you a proper representation. Pretty much good in every way. The only disadvantage is small groups of data.
Yeah, they're not very good at it. The standard deviation's not very useful.
It doesn't really mean much to anyone if you know. But is that really a disadvantage? You just don't use it, really.
Yeah.
It's not.
It's quite good. That's why big companies use it. It is quite useful. Yeah. But again, it uses all the data and can be slightly affected.
Yes. It can be affected by the extra results. But you try and eliminate that as much as you can. It's really hard, but you try to.
You can, yeah.
But those are the advantages and disadvantages of measures of spread and stuff, as well as averages.
Yeah. You just got to know that, really. We couldn't really write much on the board because
we could have wrote out what we were saying, but there's not much point.
There's not much point in that. You can hear us. That's that sorted.
And it's in the book. In our AQA book.
Yeah, we are just quoting.
Pretty much.
Yeah, but you need to be able to do that. It's quite important.
Yes, in the exam it might ask you, might be a big question, and it will say, a supervisor at this business used this. Is this appropriate? Explain why. For up to 2-3 marks sometimes.
And they're really easy marks.
They are, because they're quite easy. They're all similar.
Just knowledge stuff.
You can logic it out as well, which is good.
You can sort of, even if you didn't remember it, you could think about the median and go,
well, it takes the middle value.
Yeah, done. That sort of thing. But I think that's enough of that.
Yeah,
let's go on to practice questions.
Test yourself.
Alright, before you wreck yourself.
Yeah.
Huh.
Hello.
Hello. On to practice questions now from the book.
Test yourself, page 37, question 3 of this book.
It's quite purple.
Right.
Well,
I think I'll do part A, you do part B, and I'll do part C.
Now that sounds fair. Do you want me to read it out?
Yes, please.
Alright, here we go.
3A.
Well, apparently a chef prepares 10 meals using portions of meat bought in a shop. The masses, X grams, of the 10 portions of meat are such that sigma X equals 2000
Equals 2000.
and sigma X squared equals 409,000. Part A is finding the mean and standard deviation of these masses.
Okay.
Alright.
So you're going to talk me through what I'm doing while I'm doing it?
I think that sounds like an excellent plan.
Could you press on my calculator?
I can do that, yeah.
Awesome. Right.
Okay, so you remember our
I'll do it in green for that.
yeah. You remember our formulas? X bar is equal to this sigma X over n. We have sigma X. We know what n is. Let's do that then. So it becomes 2000 over 10, which is just 200, and that becomes 200 grams, and that becomes our mean. Think back to the formula of standard deviation. We have sigma X squared over n, take away X bar squared. We now know what X bar is, so you can put all these numbers in. We know what sigma X squared is as well. So it's 409,000 divided by 10, take away 200 squared, all in the square root sign.
Right.
I'm not going to do that in my head.
I'm going to type it down now.
Alright.
409,000
Divided by 10.
Minus 200 squared. Square root of the answer is 30.
That gives us a standard deviation of 30, and that's part A.
Right. Do you want to do part B and I'll read it to you?
I think that sounds fair.
I'll hand you my calculator. I'm not sure if you'll need it, but there you go.
I'll find out in a second. So I'll grab these things. Okay.
Yeah, probably got there somewhere.
Yeah.
Okay. Part B says deduce the mean and standard deviation of the costs of the portions of meat, given that the meat costs 2 pence per gram.
Oh.
Okay?
Okay.
Right, I'll talk you through what he's doing while he's doing it. Are you ready to go?
I think I am, yeah. Do you have a blue pen?
Not on this side.
I'll have a red pen then.
Alright.
Okay.
So, we've got the weights in grams for the mean and the standard deviation down here. And we've been told that it's 2 pence per gram. So we've got to work out a new mean and standard deviation given that. So if it's 2 pence per gram, that's the same as timesing every gram by 2. And we know that the mean before was 200 grams, so we're going to times it by 2, and it's 400. Now if you remember from our rules, this is scaling, and if you times something, both the mean and the standard deviation are affected. So the new standard deviation, because it's times, not adding, it's also affected, is 30 times 2, which is 60. And he's put it into pounds as well, which is always nice.
It is always nice.
That's all the question's asking. It sounds horrific, but it is just a scaling question.
Yeah. There's also a part C.
There's a part C. I think
So,
I'll do this
yeah,
one.
we'll swap again. That sounds like a good plan.
Could I nab that blue pen?
You could nab
It's
that
not
blue pen.
fantastically blue.
But it'll do.
It's,
Should we swap sides? Swap
Yeah,
sides.
all right.
Alright, let's do it.
Right,
Okay,
so
part C says each meal costs £1 in addition to the cost of the meat. Write down the mean and the standard deviation of the total cost of a meal.
Oh, I think I can do that.
Okay. Okay, so what Wayne's doing is he has the two values in pounds, and like a scaling question, when you add something, it adds something to all the values. And that means that the mean goes up by 1, but because everything goes up by 1, this doesn't affect the spread, so the standard deviation will stay the same. Yeah.
So there you go. I added a pound to that, and it doesn't affect that. And so I think that's £5, and that's 60p, 0.6 pounds. And I think that's it for the test yourself.
I think that is.
As usual, we've picked one that is from an actual paper. You can look on page 37, it's AQA 2002.
It is.
So a question like this could come up.
It could.
Just like this.
And
Well, it
those
has
are-
come up. It has come up.
And yeah.
But yes, good to practice. I think we should now sum up the video, I reckon.
I think we should.
Yeah.
Alright, let's crack on.
So, Unit
Yeah.
2 of Stats 1. How do you feel about it?
Yes, okay. So what did we cover?
Um,
Well, we began looking at a bit of the form, a bit of notation.
yes, the X bar, and then the variance can either be the little case sigma squared or the
Or,
SX
yeah.
squared.
Yeah.
And likewise, standard deviation can either be little sigma or SX.
Yeah.
And we looked at the formulas.
We did look at the formulas. Looked at stuff when it was in tables.
Yeah, and finding the midpoint of the intervals.
Yeah, when it was in
if it's an
frequency, so
interval.
you add them to do together. Right by 2.
Looking at your calculator and how much time it can save.
Yeah, it's very important.
Like, if you still don't know how much time it can save, try and get a normal calculator and
Then
do the sigma
these
x
things,
squared, and it
then-
takes forever
Yeah.
because of all the brackets and everything you got to do.
If you make a mistake,
It can be miles off.
mad.
Yeah. So calculator, definitely a worthwhile investment.
It is.
You need it. You can't do that paper that you're going to get in an hour and a half
No.
without that saving time.
Unless,
Because it's
You're
designed
crazy.
to do it with a graphic calculator.
yeah.
This paper. What did we go on to?
Scaling or scaling?
Oh yes, scaling. If you add something to all of the
Yeah, if all the
things
data
you're
is
list-
changed in, by the way, addition, then only the mean will change, because the same spread will be. And if you multiply
If
it,
you multiply it,
say it increases or decreases by a set percentage or something, then it'll affect all of it.
Yeah.
Which makes sense.
it's pretty much just scaling. Summed up.
Yeah, then we talked about the usefulness of each thing.
Yes. Not going to go through them all again, but we
No,
but
but
we spoke about the mode,
Spoke
the
about-
stuff, and the advantages and stuff.
yeah, you should need to know that. Didn't ask you that. And then we did a practice question.
Yeah, I think we did. I think that was it, wasn't
Yeah,
it?
that was it.
It was.
Wow.
You sure?
Well, there you go.
Not too long a video.
No?
Pretty good.
Yeah.
Definitely invest in a calculator.
Yes, we have one about how much it costs. How much does it cost?
So,
It's more than,
the school did it.
yes, it's more than a normal calculator, so it's more than like £12.
Yeah, it was above 20.
About 20, it's about 25?
More than 40.
More than 40, more than 45?
More than 45. It was 50.
50 quid, which is,
Not that bad.
Not that
it's
much,
a pretty
really.
good
It's a
thing.
pretty good
We're
calculator.
going to use it a lot.
and if you think about the investment, if you do really well in stats and really well in maths, you might get paid lots of money.
Yeah. And you can keep this calculator for uni and it will be good enough.
Yeah, it'll be good enough, yeah.
The stuff you might do there.
Yeah,
Good
it's
investment.
alright really. I think you should get one.
Yeah.
They can draw background graphs and that's cool.
Yes, they can draw a lot. It's cool.
Yeah. I think that's all.
Yeah. He's been James Trevad.
He's been Wayne Lag.
Leave us questions in the comments below, but that's it for today.
Yeah, alright. Round 3.